The Center for Connected Multimodal Mobility, or C2M2's contributions to computerized transportation systems are evident by its testbeds, labs, and software and hardware platforms. We are now breaking boundaries in transportation, cybersecurity, and resiliency to create ironclad defenses around the transportation, cyber-physical, social systems. C2M2's mission is to contribute to making the United States the leader in transportation, cyber-physical, social systems.
The more we rely on information and communication technology in transportation, the greater universe of possible disruptions becomes. We're creating the foundation of advanced cybersecurity strategies and solutions that will defend our society by hardening our multimodal transportation systems against the threats of today and tomorrow. C2M2 has a cluster of testbeds and labs that are used for evaluating cybersecurity and resiliency of transportation, cyber-physical, social systems. In our South Carolina connected vehicle testbeds, we are testing cyber attack detection strategies for a vehicle's internal and external communication network and adversarial attack resiliency of autonomous vehicles. Our Quantum AI Lab is exploring how quantum computing can make our transportation infrastructure and autonomous vehicles more secure. In addition to protecting the software, we have initiated work to find ways to make transportation-related hardware secure. Hardware in transportation and supporting communication infrastructures are vulnerable to cyber attacks such as traffic cameras and signal controllers. C2M2 researchers are testing hardware vulnerabilities in transportation infrastructure and mitigation strategies. Our C2M2 team from Benedict College and Clemson University is working to develop hardware attack resilient autonomous vehicles and traffic signal infrastructure in our labs and testbeds. The goal of C2M2's hardware cybersecurity research includes mitigation strategies against modifying the behavior of a system or gaining access to confidential data in transportation devices. When a hardware is in its normal operational state, there are many unintended channels formed, such as power, electromagnetic waves, acoustic waves, optical signals, and timing patterns. Using one of these channels, an attacker can leak secret information of the system without modifying the normal operation of the hardware. Our C2M2 students at Benedict College and Clemson University are developing strategies to detect and mitigate hardware and cybersecurity attacks at the Benedict College Quantum Information Lab. C2M2 is applying quantum computing for cyber attack detection and ensuring cyber resiliency of transportation systems. In a C2M2 project, we developed a hybrid quantum classical approach using classical neural network and quantum restricted Boltzmann machine to detect cyber attacks in an in-vehicle network. RBM is a generative stochastic artificial neural network that can learn a probabilistic distribution over a set of inputs. RBM consists of a visible layer and a hidden layer. Units within the same layer cannot be connected. Only units from alternative layers can be connected. The reason to call it restricted. Each dataset contains attack and normal CAN messages associated with a specific CAN ID that can be used to decode the messages using vehicle-specific database CAN. The decoded messages contain various CAN features. Based on the number of features available in a dataset, we grouped attack messages and normal messages to create attack CAN images and normal CAN images. A classical neural network was used to extract features from these CAN images, followed by image resizing and binary encoding. Then, the images are embedded with binary labels to obtain the final pre-processed CAN image datasets. Each label represents whether a CAN image is an attack image or a normal image. We trained 2 restricted Boltzmann machine models for each dataset with equal number of epochs, one using a classical computer and the other using the D-Wave Advantage 4.1 quantum annealer. Our analysis showed models trained using quantum-restricted Boltzmann machine achieved higher attack detection accuracies than the ones trained using classical restricted Boltzmann machine. Our students at C2M2 Quantum AI Labs are innovating new ways to protect our transportation system against cyber attacks and make them resilient. Our C2M2 Quantum AI Labs are focusing on transportation cybersecurity and resiliency, connected and autonomous transportation operations, and infrastructure monitoring. The Center for Connected Multimodal Mobility is pioneering advanced cybersecurity strategies and solutions that will defend our society by hardening our multimodal transportation systems against the threats of today and tomorrow. Please contact us if you have any questions about C2M2's cyber-physical social systems, cybersecurity, or quantum computing research.